Hello, hello, Algebra 2. Welcome to videos for section 8.4. We're going to go ahead and start chapter 8. We spent a little bit of time in chapter 5 talking about polynomial functions. Now we're going to talk about a new type of function. Now, while it's a new type of function, it's going to be kind of something you've seen before in terms of an expression. Okay, so we're going to go ahead and start with just talking about the expressions. This is a little bit of a refresher, hopefully, from Algebra 1. We're just going to apply some Algebra 2 knowledge to it. Okay, we're going to multiply and divide rational expressions. So you notice we're kind of going a little bit out of order. We're going to do 8.4, 8.5, and 8.6. Then we're going to backtrack and go to 8.2 and 8.3. We're not going to do 8.1 with the variation. We're going to talk about 8.2 and 8.3 with the rational functions themselves. But let's go ahead and practice with rational expressions first. And another reason is because you do have your midterm on Friday coming up. I don't want to throw us into rational functions just yet, especially since this will be the last thing we talk about before the midterm on Friday. All right. So our objectives are to recall how to simplify, multiply, and divide fractions. And we're going to use that knowledge to simplify, multiply, and divide rational expressions because it's kind of the same idea. All right. So let's think about how would you simplify the fraction 20 over 35? So if you had 20 over 35, you probably look at it and say, okay, what number can I divide both 20 and 35 by? Oh, that would be 5. So in your head, you probably don't write this down. Maybe you do. But in your head, you do, 20 divided by 5, 35 divided by 5. That's going to be 4 over 7, right? And that's how you simplify that fraction. Well, kind of what goes on behind the scenes is we notice, well, 20, we know that is, if I factor that down, 20 is 4 times 5. And then 4 is actually 2 times 2 times 5. And 35 is 7 times 5, right? So if we write this out like that, using this factorization, in our numerator, we have 2 times 2 times 5. In the denominator, we have, just for the sake of having the 5's close together, 7 times 5. And then notice that this 5 over 5, that's going to divide out to just 1, right? 5 divided by 5 is 1. So we're left with 2 times 2, which is 4 over 7. Now, as you can see, that was more involved, but that's what's going on behind the scenes. And that's actually going to be how we go ahead and simplify rational expressions. We're going to go ahead and factor stuff until we can factor until it's completely factored. We've been practicing that for the past few weeks, as we also practiced in 4.3 and 4.4. And we're going to see if we can divide stuff out, and that's how we simplify a rational expression. All right, so let's apply our knowledge from numbers to just numbers to now expressions. Okay, so let's simplify the following rational expressions. So start with the first one. So notice our numerator is x squared plus 7x. Our denominator is x squared. The kind of trick here, the key, is the very first thing you want to do always is just factor as much as you can. So first step, factor as much as possible. Okay, so let's see what we can do. What can we factor? Let's see, the numerator. I can take out a GCF. Notice that the GCF is x. So we factor out an x from the numerator. We end up with x plus 7 remaining divided by x squared. Now, if we wanted to, we could write x squared as x times x, just to kind of see and notice that we can go ahead and take this x and divide it by x, right? This is just going to become 1. So what are we left with? X plus 7 over x. Okay, so I hope, maybe there's a temptation, because there's always a temptation whenever I teach this, whenever I have taught stuff like this. Maybe you saw this x squared over this x squared, and you thought, oh, I can cancel that, and that's just 7x. Absolutely not. Don't do that. Okay, we don't ever want to do that, because remember, anyway, x squared plus 7x over x squared. If I want to divide this x squared into x squared, I need to be able to divide it into the 7x, right? You can kind of remember that from like if you did quadratic formula, 2 plus or minus 4 square root of 5 over 2. We could divide this 2 in because I can divide 2 into 2 and into 4. Now, if this was, say, a 3 instead, I couldn't divide it into both, so I wouldn't really bother with it, okay? So same idea here. We don't want to do that. Same thing here at the bottom with our final answer. This is our answer. Okay, so then no, I don't want to see this. Oh, x over x, boom, that's just 7. No, I don't want to see it. Okay, you'll make me cry tears of blood if you do that, okay? If you want to see your math teacher cry tears of blood, or if you don't want to see him do that, then please refrain from that, okay? No, no, no. So let's go ahead and do the next one. 40x plus 20 over 10x plus 30. So same idea. Let's factor out as much as possible from the numerator. I can factor out a 20. So I'm left with 2x plus 1. Divide each of those things by 20. Numerator, I can factor out a 10. What am I left with? X plus 3. All right. So then 20 divided by 10 is 2. And then we still have everything else. All right. So then, right, 20 divided by 10, that is 2, or you can think about it as, oh, 20 is 2 times 10 over 10. Oh, these divide each other out. So we're left with 2. However, whichever way makes more sense to you, right? And then let's check to see if we can simplify any more. This 2x plus 1 and this x plus 3, nothing I can do about that. That is good. No, none of this, none of that. Okay, that is not true. So don't do that. Okay, you're going to break my heart if you do that. X plus 3. All right, so then this is our final answer. Okay, and now notice that this 2 is factored out. We want to leave it like that. When we think about simplified form, simplified means everything is as factored out as possible. Okay, don't multiply it back in. All right, let's do one more of these simplifications. All right, we have x squared minus 2x minus 3 divided by x squared minus x minus 6. All right, very first thing we should do is simplify top and bottom as much as we can. X squared minus 2x minus 3, let's try to factor that since it's a quadratic. Okay, we need 2 factors. All right, 2 factors of negative 3 that are going to add up to negative 2. That's going to be x minus 3, x plus 1. Factors of negative 6 that add up to negative 1. That's going to be x minus 3 times x plus 2. All right, notice this x minus 3 and x minus 3, we can divide those because those are whole quantities that are the same, right? In this case, we can divide and that's just going to be 1, right? X plus 1, x plus 2, they're not the same, right? These are the same, they're identical. When I divide something by itself, I get the 1. So then I'm left with a final answer of x plus 1 over x plus 2, okay? Hopefully that sounds fine. Like I said, you probably have done something similar to this in Algebra 1 or geometry. It's kind of just the simplification game. You know, nothing too crazy. Let's keep going. All right. Now let's apply multiplication. Okay, multiplication isn't terrible. Think about how you multiply fractions. So let's talk about, 2/3 times 4/5, which is multiply straight across. So 2 times 4 is 8. 3 times 5 is 15. Nothing too bad about that. So we do the same thing here, but let's go ahead and make sure everything is simplified first, right? Always continue to keep factoring before you go ahead and do your next step. So here with part A, can't do a whole lot of factoring because they're monomials. There's nothing we can factor out of monomials. So then we kind of just keep going and just maybe simplify before we multiply. So look at this first fraction. Is there anything I can simplify with the 5 and the 2? Not really. There's nothing in common between 5 and 2. But we have x squared divided by x. X squared divided by x, if we do that on the side a little bit, we know that that's going to be equal to just x over 1. So this first fraction is going to become 5x over 2y, right? You can apply that exponent division rule, right? Because we're dividing same bases, so then the exponents subtract. 2 minus 1 is 1. Times 6xy to the third power, 10y. This y to the third divided by y, that's going to be y squared. Okay, the reason why we're simplifying now a little bit is because we're going to eventually have to simplify anyway. So let's go ahead and do some of it now while we can. Now there's actually one more thing we can do on the right-hand fraction. We can go ahead and simplify 6/10. What is 6/10 simplify to? That's going to be 3, 3/5. So 3 over 5. The y simplifies with that y cubed to become y squared. All right? So then now let's go ahead and multiply. So then I'm going to kind of multiply some like terms together. 5 times 3, that is 15. X squared, y squared, over 2 times 5 is 10, y. All right, 2y times 5, that's just going to be 10y. All right, is there anything else that I can simplify? Oh, now that I'm noticing something, sorry, I have to make a little bit of an adjustment. I kind of gave you the wrong problem to begin with. This should have been y squared. So this is y squared. So this is y squared. Luckily, it didn't affect a whole lot. Sorry about that. All right. So then, anything else we can simplify? Yes. This is 15 over 10. What can I divide each of those by? 5. So that's going to become 3x squared. Now these y squareds will simplify to become 1. So then I'm just left with 3x squared. And this 10 becomes a 2, right? Because I can divide each of them by 5. So then this is our final answer. All right, notice that we just multiplied across when we multiplied these two rational expressions together. Let's do another one. So 2x squared minus 10x over x squared minus 25 times x plus 3 over 2x squared. So then, just like we did before, let's go ahead and simplify as much as we can first. Let's factor some stuff out. So from our numerator here, what can I do? I can factor out a 2x. What am I left with? X minus 5. For my denominator, x squared minus 25, that's our difference of squares. So I get x plus 5 times x minus 5 times, can't really do anything with the right-hand side. Okay, so notice something I can simplify out the x minus 5s. So that's just a big old 1. So then now what I can do is I can just multiply straight across. Okay, so I get 2x. Let's not distribute it just yet in case there's still some simplifications we can make. 2x times x plus 3 over x plus 5. And then actually, since that 2x squared is a monomial, let's put it to the front. 2x squared times x plus 5. All right, so far so good. The reason why we put this in the front is because this is a monomial, it's one term. Usually when we have one term times a binomial or a trinomial or, etc., monomial times a polynomial, we usually put the monomial in the front. All right, so notice some things. This 2 and this 2 divide each other out to become 1. X divided by x squared, 1 minus 2, that's negative 1. X to the negative 1, we throw it to the denominator to be positive. So we get x plus 3 in our numerator over x times x plus 5 in our denominator. And that is our final answer here. Okay, remember we don't want to distribute that x back because we want it as simplified as possible. And as simplified as possible implies that everything is as factored as possible. All right, one more multiplication problem to kind of finish this off here, for the multiplication at least. Okay, so then again, let's factor as much as we can. So notice first that on the right-hand side, we just have one thing. Technically, remember that that is technically over 1. All right, so here's kind of our setup. So can we factor anything? This numerator, no. This one, if we tried, factors of 1 that add up to 1. No, the only factors of 1 are 1 in itself, so 1. 1 plus 1 is 2. So nope, we can't factor this one. That's okay though. What about x cubed minus 1? Yes, remember your difference of cubes, a cubed minus b cubed. That's going to factor to a minus b. A squared plus ab plus b squared. All right, so let's factor that this way. X cubed minus 1 is going to be, this means that a is x because x to the third power is x to the third power. And then b is just 1 because 1 to the third power is 1. So you get x minus 1, x squared, plus ab, that's just 1x plus 1. All right, so how does this factor? We get x plus 5 divided by x minus 1 times x squared plus x plus 1 times x squared plus x plus 1 over 1. Now notice above that sometimes after we multiply, everything kind of becomes the one fraction. Then I can simplify out a top and a bottom, something from the numerator and something from the denominator. I can kind of cheat and do this ahead of time, okay? I know that this x squared plus x plus 1 is going to be in the numerator. And I know this x squared plus x plus 1 is going to be in the denominator of the final fraction. So what I can do is I can just simplify these each other out ahead of time. Because right now, since this is in the top and this is in the bottom, they already are kind of dividing each other out. Okay, so you can kind of simplify diagonally. Don't think of cross multiply. Don't even let that come anywhere in your head. What we're doing is we're kind of diagonally simplifying because we know that that x squared plus x plus 1 is in the numerator, will be in the numerator of the final fraction, and x squared plus x plus 1 will also be in the denominator of the final fraction. All right. What are we left with when we do that? X plus 5 in the numerator, x minus 1 in the denominator. And that is our final answer. Hooray. All right. Let's go ahead and just bulldoze through. I was going to make a separate part, but let's just finish up with a little bit of division. And it's nothing too crazy, nothing too different. All right. Because remember, to divide by something or divide by a number, we could instead multiply by the reciprocal of that number. All right. Whenever you have, say, 2 divided by 3/2, that's the same thing as 2 times 2 over 3. You know that keep, change, flip, keep, change, flip. Maybe you guys have different little sayings for it. But yeah, pretty much change the sign to multiplication, take the reciprocal of whatever you're dividing by, of your divisor, right? We just talked about that in 5.5. Okay, so let's try that here. Let's apply that here. Okay, first, in part A, remember we always want to simplify as much as we can to start off with. This first fraction, x squared divided by x to the 7th, that's 2 minus 7, so that's x to the negative 5. We throw it to the denominator to make it positive, so 5y to the 3rd over x to the 5th. Divided by 30x y to the 4th divided by y 3rd, y to the 4th, so 4 minus 3, that's 1, positive, so it stays in the numerator. X to the first power. Sorry, x, y to the first power. So now it's technically over 1. All right, if we're dividing by this, we keep the first fraction the same. And then we multiply by the reciprocal. So 1 over 30xy. All right, so far so good. We can use kind of that same trick. Notice that this y cubed is in the numerator. This y is in the denominator. So 3 minus 1, that's going to be y squared. So 5y squared over x to the 5th times 30x under 1. And now actually we can also diagonally simplify the 5 and the 30, right? Because the 5 is going to be in the numerator and the 30 is going to be in the denominator. 5 divided by 30, what can we simplify that by? What can we divide each of those by? 5. So really, this 5 is just now a 1, and this 30 divided by 5 is 6. So now we multiply across, we get y squared over 6x to the 6th power. All right, not too bad. Same kind of idea as multiplication, but now we have that extra step involved in order to change the division into multiplication, just because the multiplication is usually a little bit easier to work with. All right, one last example. Let's go ahead and simplify as much as we can first. Notice in our first fraction, I can go ahead and factor out the 5 from the denominator. We're left with x minus 4. 4 in the numerator, divided by. What about over here? I can factor out an x from the numerator, left with x minus 2. Over here, x squared minus 6, 8 minus 8. Two factors of negative 8 that are going to add up to negative 6. That's going to be, did I write that correctly? Oh, I wrote that incorrectly when I wrote down the example. This should be a plus 8. I was like, that doesn't work out. Now it does. That should be a plus 8. Two factors of positive 8 that add up to negative 6. Well, yeah, that one is x minus 4, x minus 2. Whew! I was like, this problem didn't work out the way I wanted it to. But it does. I just forgot to change the sign. Or I wrote the wrong sign initially, not change it. All right, so then notice on the left, I can simplify these out. That's just going to be a 1. So then from there, let's take the reciprocal. So 4 over 5, x minus 4, times the reciprocal, so x minus 4 over x, because these simplified out. All right, now notice I can simplify out the x minus 4s, divide them out because they're one's in the numerator, one's in the denominator, and I'm left with, I forgot about this, wait. Something kind of went missing a little bit, I think. Sorry, I'm trying to find my issue. No, we're good. This is good. 4 over 5x. Sorry about that pause. I was just wondering if I had missed something, but we're good. Okay. All right, so that's kind of division and multiplication and simplification with these rational expressions. Maybe it's a little bit hard because fractions aren't always our favorite, but they won't get too much more complicated than this, okay? So it's just a matter of simplify as much as you can before you do the operation. That way, after you're done, there's not a whole lot of simplification left, okay? Remember, multiplication with fractions, we don't need a common denominator, just multiply straight across. Division, keep, change, flip. So keep the first one, the dividend, change it to multiplication, take the reciprocal of what would be called the divisor. All right, hopefully that helps you guys. Hopefully this is not too bad of a section before we embark on our midterm on Friday. And yeah, I will see you in class. Have a good rest of your night.